Modern woodworking. What does that really mean? Well, you probably wouldn't want to spend hours cutting a piece of lumber with a handsaw when you can just rip it on the table saw. But why am I still using a table saw? Isn't modern woodworking using the latest tools? So instead of ripping and cross-cutting a board on the table saw, I figured I could just toss the rough stock of my CNC and cut out the rectangles for a cabinet carcass. Now the CNC can also cut all the slots and grooves precisely where I need them for the carcass, while also cutting out each individual piece. But more importantly, this allows me to design without limitations. Sure, I still am bound to certain physical aspects of the wood, and I did run all my boards through my planer to get them down to exactly 3/4 of an inch thick, which was pretty important for doing dovetails. But what I'm talking about are the width and length of each individual piece. I really don't care what it is, and I don't have to make it down to a fraction of an inch just because I would be cutting it out on my table saw. Now let me step back a second. I designed this project in Autodesk Fusion, and I'm sharing it as a free download. All the cam and my toolpaths are set up in it, so you can check out the feeds and speeds for any particular operation. My name's Corbin Dunn, and I'm a modern woodworker. Now, while I have a lathe jig, I decided I'm going to use the CNC machine from now on to cut all my dovetails. It is just so much more precise and accurate. Notice that I squished my workpiece between two pieces of MDF. This is really essential to avoid any chip out. I hogged out most of the waste with a 1/4 inch downcut bit, and then I switched over to my dovetail bit, and then just did a single pass through. My goals are clean and accurate cuts. I'm not too concerned about speed. When I cut the tails, I have the outside of the box facing out towards me. I can use the exact same toolpath to do the other side. I unclamp it, flip it around, and use my same metal 1, 2, 3 block to align the top. When I do the tails, I mount them in the same way, except I have the inside of the box facing out towards me. And the reason for this is because of how the box will be aligned up when you put it together, and where one relative piece will come in contact with another one. I used a 1/4 inch spiral upcut bit to do some roughing, and then I used my 1/4 inch downcut bit to do the finishing pass, and the only reason I did this was just to try and minimize the cutting with my downcut bit to make it last a little bit longer and stay sharper. My fit was a little bit tight, so I reduced the stock to leave using a negative mount until it fit just perfect. Now the CNC cut a stopped dado for a shelf. I decided to plane down a piece until it fit perfectly in the slot. The slot was 1/2 inch wide, and the DRO on my planer dropped down to exactly 1/2 inch when it actually fit. The general rule with woodworking is to sand the inside of anything before you assemble and glue it together, when it would be a lot harder to do. I did a quick sand with 150 and then hit it with 220. So this cabinet is going to be a medicine cabinet in my bathroom, and that's a pretty wet environment, so I decided to use Titebond 2 to make sure that I don't have any issues with the glue coming loose, as it's somewhat waterproof. Now you can check squareness of a cabinet by measuring the diagonals, and mine was pretty spot on exact. I feel like there's only so much you can do when you're on the computer and you need to actually start figuring out exactly where on the board you want all your pieces to be. And I have a rough idea based on some layouts, and it's really nice in the computer to just grab things and move them around and kind of place pieces where you need to, so you can avoid any particular types of defects or anything, such as this piece has a crack on the back side of here. Now at this point I have a lot of curves to cut out, which is something that's really easy to do on the CNC machine. I spend a lot of time dialing in the speeds and feeds of my CNC machine to ensure I had a really clean finish around the outside cuts. I left tabs connecting my pieces to the outside edges, so I did have to come back with a multi-tool to cut it out, and then I did have to use a pattern bit to clean up those tabs. And you might have seen some tenons on some of those pieces. I designed and cut some tenons on all the pieces that were curved, and my plan was to use dominoes in all the other areas where it was flat. But in the end, the curve really wasn't that sharp, and a domino, based on some tests, would still work with the curved area. So I went over to the bandsaw and cut all the tendons off. I've previously borrowed a domino, and I finally bought one for myself. But unfortunately, I wasn't very happy with the quality of the particular machine that I received. I made a pretty stupid mistake using the machine to cut some of my mortises. The bottom of the machine was flush against my table, and the top had a slight gap and was kind of rocking inwards. This caused the mortises to be at an angle, and my piece was all twisted and rocked after I put it together. I hung the pieces off the edge of my table to fix this, but the mortises being recut were too loose, so I had to recut them with the next size domino up. This fixed the problem, but there was still a slight twist in all the pieces. I'll talk a little bit more about that twist in a bit. I picked a few boards for the door interior, and then I did have to use the joiner to joint them. One of the tricks of the joiner is if you joint mating faces opposite, you can basically fold them together and it will be pretty flat when you glue it up. I'm still using my 3D printed adjustable clamp stands for when I do glue ups. It really helps keep everything flat and straight. Now I'm of the camp to wipe off as much glue as I can and not have to process it after the glue dries. So I try to do that. And because I did that, I can fairly easily push the board through my planer. I accidentally made it a lot wider than I needed to be, so after I planed it down to 3/4 of an inch thick, I went and cut it down to the size I needed. I could then mount it down to the CNC and cut out into 3 pieces. Now the width of my bit is 1/4 inch, but my actual spacing in the model is a lot less, like 1/8 of an inch. So I had to kind of space them out a little bit and make sure my stock was wider so that when I glued it together I would actually have accommodated for the hole that I was cutting with the CNC machine. I ripped some thin strips of maple on the table saw. Yeah, I wasn't going to use a CNC for that. And I needed them to be pretty precise dimensions. It didn't really matter exactly how thick it was, but it needed to be consistent. And to do this, I use my drum sander. And the drum sander is nice because it removes all the machining marks from the table saw, and it gives it just a really nice, consistent edge and thickness, which is pretty important. I removed the tabs on my CNC cut pieces and then prepared everything for glue up. Now, I haven't done this before, and so I wasn't sure if it would really work. I did a dry test fit just to make sure everything would go together smoothly. The test fit went pretty well, so I decided to go ahead and glue it up. And I decided to use Titebond 3 for the glue up. Titebond 3 is also waterproof, and it just has a little bit longer of an open time than Titebond 2. Now, I didn't realize the glue would make everything a little bit slippery, and so some of the pieces weren't becoming perfectly aligned. That was kind of going to be okay because I had enough space to machine it away later, and it did work out fine. But I think if I was to do this again, I'd probably cut off the maple slats and somehow clamp it together to ensure everything was basically parallel when I glued it up. I let it dry overnight, and then I went ahead and trimmed down the long maple pieces. After that, I could use my block plane to clean up the high parts and any glue that I didn't wipe off before. That flat surface could then be used as the reference surface for planing it down until my desired thickness. And so I started out with a piece that was 3/4 of an inch thick, and my door panel thickness was 0.625 inches in my design. And I didn't want to get a planer snipe to reduce the thickness, so I followed it with a scrap piece and planed it down, which helps prevent the snipe. Now I probably could have put the piece directly on the CNC machine for the next operation, but I wanted the design to be right in the middle. So I went and ripped on the table saw and then cross-cut it, so I had a perfectly rectangular piece to start with. Alright, time to clamp it down. I started by machining the backside first. I did a roughing operation with a 1/4 inch upcut bit, and then I followed with a 1/4 inch ball nose. So this is going to be a two-sided machining operation. Usually I would use dowels for alignment, but instead I decided to just flip it, and the alignment didn't have to be 100% perfect. And while the machine was busy working, I could set up my frame pieces to cut a slot to hold the door. I used my 3D printed toe clamps to hold down the edges, but it still bowed out a little bit in the middle, so I slapped on another clamp in the middle to kind of hold it down perfectly flat against my vertical work table. My little buddy was helping me watch cut the slots, and there's really nothing fancy about the toolpaths for these. The more interesting part was watching my door handle being cut out. And the door handle is just a little slot that I kind of just worked out a size that felt good where I could kind of grab it with my fingers. I didn't take enough shots of the finishing toolpath, but it was done with a 1/4-inch ball nose to also create a little recess in it. At one point I messed up one of the pieces by setting my origin wrong on the machine, but no problem, I just tossed down another piece of scrap and cut another one to the exact same size. I sanded the door interior until it fit well in the slots, and then I just went ahead and sanded the face portions of it up to 220, and that way I could assemble it and not have to sand it later. For glue up, I put some glue in the mortises and then inserted the floating tenons, and of course no glue in the panel. You want to make sure the panel can expand and contract without actually breaking anything. I've been collecting a lot of offcut cherry wood pieces, and I decided to use all these for my back slats. And really this meant just spending a little bit of time playing them down to the 3/8 of an inch thickness that I needed. Then it was a bunch of rips and crosscuts to get them to the dimensions that I needed, and this was pretty fast to do on the table saw. Now the very top one has a 45 cut in it, and that way it will act as a French cleat. The matching one will just be screwed to the wall and won't be glued in. I then went and started gluing in all the slats. The top and bottom need to be glued in really well, and the other ones I just used a spacer to space one from the other so it had a equal spacing. I put a little bit of glue on them and then used a small nail to hold it in. Now normally you wouldn't want to glue in a back piece for a box like this, but I think just the way that the wood's going to expand, I don't think it'll be a big deal. We'll find out over time. And remember, that last piece isn't glued in, it's going to be the one that's going to be screwed to the wall for my French cleat. And at this point I had to deal with that twist that the dominoes were causing in my pieces. And what I decided to do is I could just shim it on this side that was cutting a little bit too low. It took maybe 6 pieces of blue tape on one side to get it shimmed up properly. And yeah, it's pretty far out of whack. And to be clear, I think I got a lemon of a domino and I ended up returning it. I will buy another one when I need one for another project. But this did make it aligned, and I used it to cut the mortises for my face frame. I also used it to cut some mortises into the carcass that would be used to attach the face frame onto it. Now I should have done this before I glued on the back slats, and I couldn't use the front fence on the domino, so instead I had to use the back, and to get the back to align where I wanted it, I had to just use like a 1, 2, 3 block to align it. It wasn't too big a deal, and this actually aligned things pretty well. But I made a pretty bad mistake, and I set the mortise depth to be deeper than 3/4 of an inch, and I cut through the face frame. So I could see the tenon sticking through, which was bad. At this point, I didn't really want to recut those pieces because the grain aligned really well, and I just don't like wasting wood if I don't have to. So I CNC'd a plug to fit in it, and the plug fit perfectly, but it's really hard to match the grain. I thought about it for a while, and I decided to hide it. And I was going to add an accent piece to just completely cover it. So I went back to the CNC and cut a slot. I then made a maple slat to fit into the slot, and I went ahead and glued it on in. And I made it a little bit proud to actually just make it even more of a highlighted accent piece, which I'm pretty happy with. Now the next step was to glue the face frame together. The curves would make it difficult to clamp up, but luckily I had some offcuts from when I cut out the shapes, so I went ahead and used those and just used double-sided tape to attach them onto the sides of my piece. And this would make the curves be the right orientation to get some clamps on. And I've started doing a dry run of the clamping process. This really just helps me work through any errors that might happen. And in fact, I realized I needed some more of these pieces to be on the side so I could kind of get all aligned with my carcass. Now for the actual glue up, I'm only gluing the face frame together and I am not gluing it to the carcass at this time. But I'm using the tenons on the carcass to help align everything. The position with respect to the carcass is pretty much exactly where I want everything to line up. And this way I can kind of shift things slightly and get it to be right where I need it to be. And then a few hours later I could remove the clamps and I could remove those little glue stops that I had double-sided taped on. I could then carefully ease the face frame off. It had only been 2 hours and that's enough time for it to start setting up, but it doesn't have a lot of strength with the glue yet. I could directly go into gluing the face frame on at this point, so I ran a bead of glue around the outer edge and filled up the tenons. I also decided to try something new, adding a little bit of blue tape to help with any squeeze out. Tenons actually aren't really necessary when you're gluing a face frame on, but they really help a lot with alignment. Okay, so the face frame is glued onto the carcass, and the next step would be for a typical type of cabinet is to trim up the door to fit perfectly within the space. But the CNC machine made it pretty darn perfect. And when I shove my door down into a corner, I can make sure the gap is twice the thickness of my reveal gap. My reveal gap is going to be 3/32 of an inch, and twice the thickness would be 3/16 of an inch. And really it's just a matter of it looking good. And really it looks pretty darn parallel and straight. The only issues I see is I have a slight gap when I shove the board to the left, a slight gap up here on my top piece. When I shove the board to the right, I can see the opposite is true. I have a slight gap down at the bottom piece, which means that I just didn't get this top piece quite aligned. It should have gone over about 1/64 of an inch. So I'm going to trim it up just a tiny bit. And really that meant just about 2 or 3 light swipes with my block plane. I went with the Blum soft closing hinges because they have a lot of adjustability in them and they look really nice. It's not too hard to interpret the data sheet and figure out where you have to lay out the lines for the screw holes. I did have a slight issue with the screws intersecting the panel, and this is going to probably make them a little bit weaker. I should have not put the panel so deep as I did. I did punch the hole location and pre-drill it a little bit to make sure the screws go in really easily. And I did all this test fitting before I did any final sanding and putting any finish on. That way it could address any issues before I went and did all the finish work. So I did a bunch of sanding down to 220, but that's kind of boring to watch. So let's go on to finishing. I used Osmo Poly-X to do the finish, and you basically wipe it on with a white Scotch pad, and then you basically wipe all of it off with another rag, and you just leave a very tiny thin film on. I put one film on, and then I wait about 8 to 12 hours and put a second coat on, and then let it dry too.